Hello fellow gamers, my name is Brent Justice and welcome to the thefpsreview.com's YouTube channel. Today it's all about the Ryzen 9000 series CPUs from AMD. Here's three of them right here in my hand, the 9900X, 9700X, and 9600X. And then right behind me in this testing computer is the 9950X. So that's all four of the new Ryzen 9000 series CPUs based on the Zen 5 architecture that we have reviewed for the launches of each CPU. So this is going to be a long form video today. This is a deep dive into the performance benchmarks that we experienced. I'm going to show you all of our performance graphs from our written reviews and go over that performance with you today. However, our written reviews do have more detail, all the specifications, the analysis of performance, and the percentages calculated under each graph in those written reviews, so check them out for a more detailed explanation of what all this means and our thoughts and opinions as well in those reviews. Before I go into all the performance benchmarks today, let's quickly go over the specifications, just some quick general specifications of each CPU so that you know what these are. These are the Ryzen 9000 series CPUs based on the Zen 5 architecture for the AMD AM5 platform. The 9900X and 9950X are the two top-end CPUs. Those were launched on August 15th, and then the 9700X and 9600X, those were launched on August 8th. So starting at the top is the 16-core, 32-thread Ryzen 9 9950X, a 170-watt TDP, 5.7 gigahertz maximum clock with an MSRP of $649. Below that is the Ryzen 9 9900X, the 12-core, 24-thread CPU, 120-watt TDP, 5.6 gigahertz maximum clock, and an MSRP of $499. Below that, the Ryzen 7 9700X is the 8-core, 16-thread CPU with an 65-watt TDP and 5.5 gigahertz maximum clock. Then finally is the Ryzen 5 9600X, which is also a 65-watt TDP CPU, 5.4 gigahertz maximum clock, and an MSRP of $279. That is how all of that plays out. You might also see this huge pile of CPUs behind me. We have all the Ryzen 7000 series, previous generation, as well as the Intel 14th gen competition as comparison. So our review has all of those CPUs in the graphs. And I also have the boxes here that each CPU came in. These are the two Ryzen 9 boxes for the Ryzen 9 CPUs. And then we also have here the Ryzen 5 and Ryzen 7 boxes as well. So that's what the boxes look like that these new CPUs will come in, and you'll notice none of them include a cooler. It is just the CPU only. All right, so the way this is going to play out is I'm going to bring up the graphs and we're going to go through all the performance, and I'm going to talk about that performance, and I've got chapters in the bottom, so you're welcome to skip through to the sections you want to see. But again, the more deeper analysis and percentages are in our written reviews, link in the bottom, so check those out if you want more detailed information on that. But the first thing I'm going to bring up now is our test setup page so that you can see what our test systems were, and I want to explain that just a little bit before I show the benchmarks, and then we'll get right into the benchmarks. Also, the graphs are separated. The Ryzen 9 CPUs are on a separate graph with the competitive CPUs that relate to them, whereas the Ryzen 5 and the Ryzen 7 CPUs are on a different graph with a different set of CPUs that they are being compared with. So two sets of graphs, and so you'll be seeing the same graphs, but they will have a different set of CPUs in each graph, but I'll explain that as we go through. All right, let's switch over to the graphs and we'll get started. And hello everyone, this is how the format's going to be. Hello, I'm in your corner screen. This is our system setup, and I wanted to show you this table so that you're aware of how we set all of this up. Both of the Ryzen 7 7000 and 9000 CPUs were tested on an X670E motherboard, the exact same motherboard. The 7000 series used BIOS 2124 because that was the latest BIOS at the time of testing. AMD provided a new BIOS 2201 to use for the 9000 series, which we did. All that BIOS changed was that it added a patch A to the AGISA version, which basically added some fixes for 12-core and 16-core 9000 series CPUs. Otherwise, the AGISA version is the same. It's 1200A, so both CPUs, 7000 and 9000 series, both had AGISA version 1200A, so they had the same version. It's just that the 2201 added a patch A to that for the 9000 series, so nothing would have changed between those two BIOSes. Wanted to mention that there's been some confusion about, do you need a new BIOS for these CPUs to really get the maximum out of them? But it was the same AGISA version that the 7000 series was tested with, so there was no difference there with that. Perhaps in the future there will be newer BIOSes and versions coming out that could provide enhancements. Right now, this was the latest at the time of testing, and that BIOS was provided by AMD. Otherwise, the RAM is the same, DDR5 at 6000 that we are running here, and we are running 1-to-1 with that memory controller and the memory. The F clock, however, note, is at 2100, so it's not at 2000, it's at 2100. However, it's at 2100 on every CPU, so that is comparable. But the memory ratio is 1-to-1 memory controller to DRAM. So that's the important part there for the latencies. That's what we were running. And you can decouple F clock from the memory controller and DRAM with the 7000 and 9000 series just fine. It's just you want to keep the memory controller and DRAM at a 1-to-1. But the F clock, if it's stable, you can clock that higher. 2000 is AMD's recommended setting for stability. But our motherboard configuration, the BIOS we're using, and all the hardware we're using automatically ran that at 2100. So that was an automatic setting. We did not set that. That was left on auto or BIOS defaults, and that set it to 2100. But it was the same for all the CPUs. So just wanted to mention that. We are using a 360mm AIO as well for cooling, and we're using the latest AMD chipset drivers. These were the latest on their website at the time of testing. This is important because the Ryzen 9950X and Ryzen 9900X, both of those CPUs do use core parking. They require the AMD PPM provision driver in the chipset driver for core parking. That's very important. The 7950X and 7900X does not require core parking. It doesn't need that. It doesn't need to do that. It doesn't need to do any kind of provisioning for the cores. However, that has changed with the Ryzen 9 9950X and Ryzen 9 9900X. Those are very important to install the latest chipset drivers and make sure all of that is set up and working correctly. Yes, that means it relies on the game bar, the Microsoft Xbox game bar, for that to work properly. So make sure it's updated before you do testing. We did make sure it's all updated. We have all the Windows updates. We have all the Windows Store updates. We have the game bar updated. We have the latest chipset drivers. So all of that was done in all of our testing, and it's very important. Note also that we do have the core isolation or memory integrity disabled. The core isolation, that is disabled in all of our testing, every CPU. It is as equal as can be. The NVIDIA GeForce RTX 4090 Founders Edition, same video card for all the CPUs with the same driver. Now for the Intel system, we used a Z790 motherboard from Asus. It also had the latest BIOS installed, and we used 7200 megatransfers per second DDR5. Same AIO on that, same everything else. We also had the latest chipset drivers from Intel on that one as well, and all the updates also. Now, the thing to keep in mind about the Intel setup is that this did not have the microcode fix. So this particular BIOS, 1661 we were using, that did not have the brand new microcode fix for the stability. However, it did have the new Intel default profiles in the BIOS. It had the extreme profile and the performance profile, two different profiles. We tested both of those. We tested it in the extreme profile and the performance. We left it at the Intel defaults, which was the motherboard defaults. We left everything else at defaults. SVID was also at Intel failsafes. So everything was at the new motherboard Intel defaults profiles set with this BIOS. However, it does not have the microcode fix. So keep that in mind. That probably won't change performance too much on Intel, but I just wanted to mention it so you're clear on what's being tested here. That BIOS is what's being used for all of these benchmarks, and we did make sure to test both the performance and extreme profiles. If you want to see screenshots of what that BIOS looks like, our written review articles have that screenshot of the BIOS so that you can see exactly what we're talking about here. But I want to get all that configuration out of the way because it's extremely important right now when we're talking about performance between these CPUs because of all the new things about the Intel stability problems, performance that can change over time on that one because of the new BIOS, and then also what could change in the future for AMD with new BIOSes coming out. You never know. We may get new AGESA versions that, really improve performance over time. And again, this was tested with the 1200A patch A. So if that changes over time, we'll see. But that's what we've got right now. This was the latest at the time of testing, the absolute latest for everything. So that's all we could do. Okay, let's go into the performance and take a look, shall we? All right, we are now looking at the first graph. Now, as I mentioned, the Ryzen 9 and the Ryzen 5 and 7 CPUs are going to be using different comparisons for the CPUs. So therefore, we have two different sets of graphs. Same benchmarks, just two different sets of graphs because it would have just been way too many for one graph. So on these first sets of graphs that I'll be showing you, we'll be looking at the Ryzen 9 9950X, which is highlighted blue, and we're also going to be looking at the AMD Ryzen 9 9900X. So both the 9950X and 9900X are on the graphs. The 9900X is not colored. It is just the 9950X that's highlighted. And we also have the previous generation 7950X, previous generation the 7900X, also the 7950X 3D as well, the 3D V-cache. And then here is the 14900K from Intel with the extreme profile, as we mentioned, and the performance profile. So this is PC Mark 10 Express Test, PC Mark benchmark. This is the Express test of PC Mark. Now what this test is a very, very lightly threaded, very simple workload. This is typically what you would experience in an office situation. If you're using your computer for productivity, for office level work, Microsoft Office, for example, this is the kind of performance that it tests. So when we look here at this graph, the first thing you'll notice is right off the bat, the 9950X is at the top of the charts. It is beating the 7950X, the previous generation. And then the 9900X is also impressive because it is beating the 7950X and of course the previous version 7900X as well. So topping the charts in this office style work, the 9950X and 9900X do take the lead. This also leads over the 14900K in either profile mode. So that's a great start starting off. Again, if you want to see all the percentages and what these actual percentages are, that is written down in our written review under each graph, so you can check that out. I believe for this one it was 8%. The 9950X is 8% faster than the 7950X, so that gives you about an idea of where we're starting off with the percentages there. It's under 10% for this level of activity or workload. Moving on to Geekbench. Now this test multi-core, so this is where all the cores are being put into use. Naturally, the 9950X is faster than the 9900X because that's 12 core versus 16 core. But what you really want to look at is the difference between this, the 9950X, and the 7950X. It's not a lot, and if you do the percentage calculation there, you'll find that that is actually a pretty small difference. It is faster, yes, but it is well under 10%. The 9950X, though, I think it's a little bit more over the 7900X, has a little bit more of an advantage there. They are still at the top of the chart compared to the AMD CPUs, except for the 14900K. Even in the performance profile, it beats the 9950X in the multi-core testing for Geekbench. Now, if we go to the single core, this is where Zen 5 shines, single core performance. You will find the 9950X just way up there, just doing a whole lot more than the Ryzen 9 7950X. And the 9900X, well, it's also up there. It's beating even the 14900K. It's even beating the 7950X. They're just at the top of their charts here with the single core performance. It's very good, very strong single core performance out of these. And I think what we'll see in 3D Mark is an up to between 14 to 16% performance uplift on the single core performance with the Ryzen 9 series versus the previous Ryzen 7 series or Ryzen 7000 series. Looking at 3D Mark max threads, we also see the 9950X at the top, 16601, which is beating the i9 14900K in the extreme profile, which is operating at 253 watts for that CPU, whereas the 9950X, 200 watts. Socket power of 200 watts. Big difference, and yet it's outperforming it. It beats, of course, the 7950X from the previous generation. And then you look at the 9900X. Now that one isn't as impressive. However, it is a 12-core CPU, so these higher core and thread count CPUs are winning in the max thread testing. But we do see an uplift compared to the 7900X, but it's not a huge one. It's a smaller uplift there. So that's how that pans out. Now when we go to the single thread, well, that's where things flip again. The 9950X and 9900X are just at the top of their game. Even the 9900X is beating the 14900K in either profile mode. And then here's the 7950X down here and the 7900X. Just a pretty big jump, really, for the single thread performance in 3D Mark. Performance test is just an overall test of the CPUs. It tests everything about the CPUs, so it kind of throws everything into the bucket on this one. We also find that CPUs with 3D V-cache do really well in this benchmark. So the 7950X 3D is doing remarkably well in this benchmark, where it's not so much in the other benchmarks. So throws that off a little bit, so keep that in mind. But we do see the 9950X just doing a lot better here. And it's better than the 7950X, better than 14900K. We see the 9900X down here. Thread count does matter, core count does matter, but it is doing better than the 7900X from the previous generation. Now, looking at IDA64, we want to look at memory read and write bandwidth. Intel takes away the cake here. The cake is definitely no lie with Intel and memory bandwidth. The read and write performance is just incredible. But really the big takeaway from this is just the fact that nothing has really changed in the memory bandwidth department with the Ryzen 9000 series compared to the 7000 series. Zen 5 versus Zen 4, no difference in memory bandwidth. Memory controller, not really seeing any difference there with memory bandwidth performance. It's the same. So let's move on. zlib, this one tests integer performance in IDA64, and for this one we can really thread count and core count is also important. We can see the 9950X just doing way better than the 7950X, definitely a bigger improvement. The 9900X is doing better than the 7900X, but it's not as huge of an improvement. The 14900K is up there, but even the 7950X was beating the 14900K in this benchmark. So impressive there for those higher core count CPUs. Now this is the one we really want to focus on. This is AES encryption, and this is where Zen 5 just blows the door off of everyone. We are seeing, I think this was like a 78% performance improvement from the 9950X versus the 7950X. It's huge. It's huge. And I think versus the 14900K, it's about 134% performance improvement. So that's huge. That's huge. And that is thanks to AVX. Zen 5 is all about that AVX performance, and we're seeing that play out here. So, I mean, even the 9900X is just blowing everything away here. And, I mean, this is an outlier in the other tests because none of them are this much of a performance gain. This is the only one that is this much of a performance gain. But it does emphasize what Zen 5 was built for, and that is AVX type of workloads, workstation server type workloads. It's good. It can be good. That potential is there in Zen 5 if you're doing that type of workload. But it is an outlier, obviously, if that's not your main thing that you're doing. All right, good old Cinebench, and this is R23, not the new one, not 2024. In this, we are seeing an uplift over the 7950X to the new 9950X. It's not huge, but it's there. We are seeing also a slight uplift from the 9900X from the 7900X. And then we are seeing the 9950X over the 14900K. And the 9900X is lower because of the thread count difference. Now, in the single core test, this one's interesting because we didn't see this in the other single thread tests that we did, but for some reason in Cinebench, the 14900K just does extremely well. And that wasn't the same in 3D Mark or Geekbench, but it is here. So the 14900K is faster in the single core testing in Cinebench. But the 9950X is doing really good, and the 9900X as well, again showing that big improvement versus their Zen 4 counterparts. And that's really the story in the narrative here, is that versus Zen 4, they're getting a pretty good single core uplift or single thread performance uplift there. And at times it kind of competes with a 14900K or can be better just depending on the application. All right, Blender. So in this one, what we're looking at here is the Blender benchmark with Blender 4.2.0, Monster, Junk Shop, and Classroom. And we're looking at about a 10% uplift overall between the 9950X and the 7950X, about a 10%. So it's a general uplift, and it's good. Everyone there is good. It's just not more than 10%. We all are also seeing an uplift with the 9900X over the 7900X, and it's decent, but not huge, right? It's not mind-blowing. It does allow the 9950X to do better than the 14900K, and the 9900X is below the 14900K because of the thread count difference. So that's how that ends up. V-Ray 6 got a little bit of a bigger boost than some of the other benchmarks. Not sure why, but on this one we saw like a 20% uplift from the 9950X versus the 7950X. So a little bit of a bigger jump here. This was one of the larger jumps, actually the largest jump with all the other rendering benchmarks that we did. And same with the 9900X over the 7900X here. In fact, that puts the performance on the level of the 14900K. So the 9900X in here is on the same level as the 14900K in performance. So for whatever reason, maybe this uses AVX in a certain way that really benefits Zen 5, but we are seeing a bigger boost here with the V-Ray 6 benchmark. So if that's a workload you use a lot, yeah, you're going to find a benefit there. Handbrake. Now on this one, what we are doing is transcoding a 10-minute video into the Creator 2160p 64K H.264 profile. And this is the time it takes to render. So you want a less time. The less time, the faster. And we are seeing the 9950X with the fastest time of 7 minutes and 15 seconds there. However, it is small compared to the 7950X. I think that's about a 2% difference there. It's a very tiny difference. So it is there, but it's a small difference. And we are, however, seeing a bigger difference with the 9900X compared to the 7900X. That one's a little bit more, not a ton, but a little bit more. So a little bit more with that one. So yeah, they're an improvement over the previous generation, but they don't blow my socks off. Now we're looking at CPU power. The 9950X has a socket power of 200. So yes, the TDP is 170, but the PPT is 200. And we're exactly hitting that 200. With the 9900X, its PPT is 162 and we are exactly hitting 162. So yes, it's a 120 watt TDP part, but the socket power is 162 watts. So we're hitting exactly what AMD says we should be hitting on this. This is an all-core full workload using a Cinebench R23 for 10 minutes. So this is the worst case scenario, maximum spiked power. This is not a graph of like power while gaming, which would look different. This is a spiked power with all cores being pushed as hard as possible. We are hitting that socket power. But how that lines up and what that means is the 14900K is now locked at 253 watts with these new profiles. Intel defaults, it's locked at 253, so that's what we're getting. But really the comparison you want to look at here is a 7950X because it has a 230 watt PPT. And we can see that it's hitting that 230 watts. So the 9950X, yes, is running 30 watts lower right there, right off the bat. It is producing above performance to the 7950X at 30 watts less power. And we also see that for the 7900X versus 9900X. This one goes up to about 193.5, and the 9900X is 162 watts socket power. And yet it was giving us better performance at a lower power. Now again, maximized, full throttle, spiked power, maximum usage. That could look different if you are doing a more up and down kind of power curve. How it looks along that power curve will look different. This is just showing the spike. But this replicates the benchmark results that we saw in the Cinebench R23. So it's the same benchmark of Cinebench R23 multi-core test. So if we go back to that benchmark, then we can look and see that yes, then at that power that it was delivering, the 9950X is giving more performance at less power than the 7950X in this benchmark. The 9900X is giving more performance than the 7900X at less power. So this is that test and the power from this test. And it does show that this test is giving more performance at less power. And that's just a straight up fact of those two CPUs. So when we look at the temperature difference, keep in mind that this can be a little different as well, depending on where the sensor is in the CPU and depending on many other factors as well. But we are using the same AIO here, and we can see that the 9950X is running cooler at 78 degrees Celsius than the 7950X at 95. And we can see the 9900X at 71 versus the 7900X at 94. And the 14900K can also get up to 95C as well. But again, just keep in mind, sensor placement in the CPU will be a little bit different of where it's reading that temperature from. Take that for what it's worth. Just keep in mind that the sensor placement of where it's reading that sensor in the CPUs can be a little bit different. This is what Hardware Info showed us with this data on the same AIO. So just take that information, you know, and put that in your mind and jumble it around with all the other information you've learned about these CPUs today. So that is the 9900X and the 9950X. And now it's time to jump in and look at the 9700X versus the 9600X and all the productivity stuff. After we do that, then we're going to go look at gaming performance, and you're going to find that interesting as well. Okay, now we are looking at the AMD Ryzen 7 9700X and the AMD Ryzen 5 9600X. Similar to the last graphs, these are the same benchmarks, but you will notice the Ryzen 7 9700X is highlighted in blue. The AMD Ryzen 5 9600X is not highlighted, but they are both on the graphs. And then compared to that is the AMD Ryzen 7 7700X, AMD Ryzen 5 7600X, Intel Core i5 14600K, AMD Ryzen 7 7800X 3D, and Intel Core i7 14700K. So this is all of the similarly comparable CPUs put together here. Again, same settings, same BIOS, same software, same everything. All of the CPUs are reformatted between AMD and Intel with brand new installations of Windows and applications and games, so they are fresh install for each platform as well. Okay, so starting off in PCMark 10's Express benchmark, again, a lightly threaded workload, something that is more office productivity related. The Ryzen 7 9700X and 9600X both are equally as fast, and they are faster than their counterparts. The 9700X is sitting here over the 7700X, and the 9600X over the 7600X. So these CPUs were all very similarly performing here. The 7600, 14600K, 7700X were all kind of similarly performing, but you can really see that these two new CPUs kind of set themselves apart. It's not huge results, not huge differences, but this one's pretty decent. This is pretty okay. It's not mind-blowing, but it's okay, and it's there. It's noticeable. Moving on to Geekbench multi-core testing, we're looking at the 9700X here, and then that is sitting above the 7700X. Again, these are 8-core CPUs. We are getting better performance. However, the 14600K and 14700K much better because of the thread count difference, thread count difference there. The 9600X is better than the 7600X. It's benchmarking a little bit faster. Again, it's not mind-blowing at all, but it is showing some difference there. Is it what we expected? Maybe not, but it is something. Now, let's look at Geekbench 6 single core. Now, similar to the 9950X and 9900X, single core is where these CPUs shine. So the 9700X and 9600X are definitely well above the performance of even the 14700K, 7700X and the 7600X. The single core performance greatly improved. This is where Zen 5 has its strength, is in that single core performance. In 3DMark's max threads test, we are looking here at the 9700X. Now on this one, this was interesting because we are pretty much getting the same performance as the previous generation Ryzen 7 7700X. Now in Geekbench, it was faster. Now those test different kinds of workloads. Geekbench does test several different things, including some more Zen 5 specific things that benefit Zen 5, like encryption type of things and things like that. 3DMark doesn't do that. It is more of a straightforward one single type of benchmark workload. So if we look at things that benefit the Zen 5 architecture, like Geekbench can do in some of its tests, we saw a performance improvement. However, in 3DMark, with this one single workload, it's really saying here that the 9700X is the same performance as the 7700X. So that's interesting, isn't it? And we also see the same, but a little bit better with the 9600X versus the 7600X. That one actually has a more decent uplift, and that's what we would have expected from the 9700X, but really did not get here. The 7600X versus 9600X, that one though we did see some. Now for the 14700K and even the 14600K, they are definitely better with their thread count. Looking at the single thread testing though in 3DMark, well, this replicates what we saw in Geekbench. The 9700X and 9600X well above the 7700X and 7600X. Definitely a huge advantage with the single thread. I don't think anybody can deny that. Single thread performance, it's up there. All right, Passmark's performance test. This one, again, is more of an everything benchmark, and we are seeing a little bit more performance out of that 9700X versus 7700X, but similar to 3DMark, it's actually rather small, very, very tiny, actually. It's there, it's just tiny, and the same with the 9600X versus 7600X, and this one is just really showing that not as advantageous there. All right, IDA64. Now this one shows the read-write performance of memory, and again, similar to the 9950X and 9900X, the Intel takes the lead on bandwidth, but the 9700X versus the previous generations, honestly, it's not a huge difference. We are seeing a little bit faster on the 9000 series here, but it's pretty much similar performance. just a little bit faster. For some reason, these the bandwidth on these is just a little bit higher. And moving on to IDA64 CPU zlib. This one is again an integer test. 9700X is, well, just a little bit faster than the 7700X. Similar to 3D Mark, we're just not seeing a whole lot there. 9600X, that one's a little bit more over the 7600X, but we're talking very small percentage differences here. One can argue that the power is different between them, but maybe not so much as you think it is. Maybe not so much as you think it is. The 9700X and the 9600X are very good in AVX workloads. We've already talked about that. AES here, it just blows the doors off of the previous generation. This is a Zen 5 architecture thing, and this is one of the tests where it just really shows that when you are in the right workload for Zen 5 to benefit, you are going to see a large benefit over Zen 4, but you have to be in that right workload. You have to be in that specific thing to really see that advantage. But when you do, it's huge. But if you don't, it's not so huge. Cinebench. Yeah, we're kind of seeing the same thing we saw in 3D Mark and zlib test. 9700X is just barely over the 7700X, not too much there. The 9600X is a little bit more over the 7600, but not as much as we would have hoped for. But that 9700X is a little bit disappointing over the 7700X. Yes, technically the socket power is lower between them for sure, but that's going to vary. Really is going to vary on that power curve of where you are. If you're pushing all the cores, something like this test does, then okay, yes, it is performing the same or just slightly better at a less power. Cinebench R23 single core, we are seeing the 9700X and 9600X, of course, really excel over everything else. Again, single thread performance is just good. It's just good. You really cannot deny that. Blender, we are seeing some slight performance uplifts versus the previous gen, 9700X versus 7700X, but they are tiny. They are tiny. 9600X is a little bit more over the 7600X. I say that one is definitely a bigger advantage over the previous generation than the 9700X is. We look at V-Ray. This one gets abnormally higher results. It did in the last set of graphs as well. The 9700X is actually showing a pretty decent uplift over the 7700X now in this one. This is what we would have expected in every other test we looked at. We would have wanted this kind of uplift with it, but we're only getting that in very specific scenarios. The 9600X, same one there as well, much bigger in V-Ray here. And that puts, in V-Ray, it puts the 9700X on par though with the 14600K, so keep that in mind. 14600K. Handbrake. This one, yeah, this is unfortunate. So we actually got a longer time with the 9700X. That's a worse result. So you'll notice it took 13 minutes here and it took 12 minutes and 28 seconds here. So that's a longer result that it took for the 9700X versus the 7700X in Handbrake. Again, both CPUs are the same core count, same thread count. So we're just looking at architecture or power differences here maybe, or frequency differences. And the 7700X is beating it. So in transcoding, might as well just stick with the 7700X if you use a lot of Handbrake, right? The 9600X, I mean, it's pretty much on par really with the 7600X. It's slightly faster, but just tiny, slightly faster. Yeah, not really seeing much of a difference there in the Handbrake performance, transcoding performance between the CPUs. So interesting regression there with the 9700X. Now, CPU power. So keep in mind with this one that the 9700X, 9600X both have a PPT or socket power of 88 watts. So that's why you're seeing that max out to 88 watts. They are a 65 watt TDP, but the PPT is 88 watts. So they're hitting what is claimed. And same for the other CPUs. The 7600X is hitting 119 watts. 7700X is 142. So yes, again, this is a Cinebench R23 test. So if we look at the maximum power or PPT that these are hitting, the 7700X is pulling 142 watts. The 9700X is only pulling 88 watts. So if we go back to Cinebench, that means it's giving the same performance at less power. So in this benchmark, that is true, but it's not true of everything, because this is just constant maximum peak power. It is not power over the entire power curve, and it's not voltage either. We're not looking at voltage, which could be different between the CPUs at the power levels as well. So voltage could be different. We're just looking at the power as reported by Hardware Info. So if we look at that, of course, compared to the Intel offerings, I mean, that's night and day. 253 watts on the 14700K and 181 on the 14600K. So at times, the Intel CPUs were faster, so you could argue that that power may be worth it if you need that performance. But if you do look at the socket power of what the Zen 5 CPUs were providing, then it is a pretty big improvement over the competition in that sense. And really the 7800X3D, I would say it's definitely a value for power there as well. Even though it's not the fastest multi-threading performance because of clock speed and everything, it's still only at 90 watts when it's fully loaded, and it wasn't terrible performance. And again, you cannot beat the 7800X3D for gaming performance. So for gaming performance and value for power in gaming, the 7800X3D is just the way to go, bar none. For temperatures, 9700X and 9600X, again, very good temperatures, but just be careful about this comparison here and where those sensors lie. But with the same AIO here and the temperature readings we're getting, I mean, it's a positive result in this comparison. Just put that in your mind and jumble it around with all the other data points we provided to make a comparison yourself for what all that means. Okay, at this point, I want to jump into the gaming performance, and we're going to talk about that. And again, the gaming graphs are going to be divided between the 9950X and the 9900X, and then the 9700X and the 9600X. So they're divided, so I'm going to show them twice. We have 8 games that we tested total. All right, now let's look at the gaming performance. I am going to start with the 9950X, and that is highlighted here. And then I've also got the 9900X on all of these graphs as well. They're not highlighted, but it is on the graphs. Now, let's talk a little bit about how we set this up and how we did this. We tested all of these games freshly installed on a GeForce RTX 4090 with the same driver. I am testing at 1080p, 1440p, and 4K in 8 games. So all 3 resolutions tested. The one you want to focus on is 1080p. That's going to be where it shows you the most difference between the CPUs so that we can see what would benefit a future generation GPU, which one can provide faster frame rates to the GPU and how many frame rates you can get for the GPU. You're going to want to look at the 1080p results. But we are starting to see 1440p affected by that as well with fast GPUs, especially the 4090. We are seeing 1440p where there are performance differences. You can even see that right here on the graph, going between 129 up all the way up to 133. So there are some performance differences starting to happen at 1440p that are important. And that is important because if you play at 4K, for example, but you use upscaling in games, well, that's going to be upscaled from a 1440p resolution. So that matters then, because you are going to be using the CPU more. That CPU is going to be more necessary and effective if you're using upscaling a lot. So just keep that in mind. That's why we show all 3 resolutions, and then 4K is in there because it's in there. Is it going to show a difference between the GPUs? No, not really, but it's there. So we include all of that. We have 8 games here. Naturally, you want a larger size sampling for gaming performance between these CPUs, and we will have that in the future, so stay tuned. We will do a much larger 15 to 20 game roundup of performance on these CPUs to really hone in on that. So this is just an 8 game. Take it for what it is. These are very current games, though. They're not real old, so keep that in mind as well. We wanted to try to get some more recent games in there. We even have a UE5 game in here as well. So let's look at Alan Wake 2. So looking at Alan Wake 2, the 9950X versus the 7950X, that's what you would want to compare these two. We are seeing a small uplift. It's not big, but it's noticeable. In fact, the 7950X had the lowest performance here, but 9950X, it pushes up there beyond even the 14900K in the performance profile. And it offers a little bit more than the 9900X as well. And of course, the 7950X 3D is at the top here, and it's right up there with the 14900K in the extreme profile. Both of these are kind of similar. But the 9950X is just right below those two. I'd say these are the two fastest CPUs for gaming, 14900K in the extreme profile, and the 7950 3D V-Cache version would be the fastest, and you're going to see that in all these results. Those are pretty much the fastest, and then it's followed by the 9950X. So there is a little bit of an uplift versus the 7950X. It's not huge, but it's there. Now the 9900X, however, versus the 7900X, that's not so much. It's pretty much the same performance. So we're not really seeing an uplift here in Alan Wake with those two CPUs. Assassin's Creed Mirage. Oh, also, all of these games are being run at ultra settings, not high, not medium, not low. Ultra settings in all the games. Okay, again, we see the 7950X 3D at the top. That's what we expect. 14900K we would also expect near the top. That is happening definitely in this game. In fact, these three here with these two profiles and then the 7950X 3D pull way ahead of all the other CPUs here. 217, 218, 220 versus, you know, at 200 here. So there's actually a 17, 18, 20% performance difference between these CPUs and these CPUs, which is notable. That's very notable. But really here, the big thing is the 9950X is no faster than the 9900X here. We're pretty much, or the I should say the 7950X, a few frames per second, but not huge. And then the same here, 9900X versus the 7900X, same performance between these two. Exact same performance, no difference at all in gaming performance. It's that 7950X 3D you just can't beat. When it's working right, when the cores are parked correctly and it's working right, it's a beast in games, just like the 7800X 3D. All right, Avatar, Frontiers of Pandora. Now, something to keep in mind about this game, it runs ray tracing at all times. You can't turn it off. This is a UE5 game, but ray tracing is turned on all the time. Now, even at 1080p though, we wanted to include this game because of that fact. But also because it's a UE5 game, all of the CPUs at 1080p are practically the same performance. I mean, we're talking 1 or 2 FPS difference here. The 9950X versus the 7950X, I mean, it's the same. The 9900X versus the 7900X, it's the same. So no difference here, really. Even with the 14900K and 7950X 3D, I mean, we're within margins of error differences here. So we just wanted to include this one because sometimes a non-result is a result. The fact that there is no difference sometimes is important as well. Well, it is important. If there is no difference, that's important as much as there is a difference. So we wanted to show that. Everyone's favorite, Cyberpunk. Now this one has some pretty big differences actually. That 7950X 3D, again, when it's working right, it is great. It's good. 14900K, it's up there as well. 9950X. Now here's where, yeah, once again, another game where between the 7950X and the 9950X, same performance. Now the 9900X, we're actually seeing a regression. So check that out. 185.5 on the 9900X, on the 7900X, 197.6. Faster performance on the 7900X. Now remember I told you that the 9950X and the 9900X now use the PPM, or the that component, that provisioning component that's within the chipset drivers for AMD, core parking, it can also be called, and the Microsoft Game Bar, all of that is important on the 9900X and 9950X, whereas you did not need it for the 7900X or 7950X. It's very possible that's causing a problem here. Maybe cores are not being parked correctly. Maybe the provisioning is not hitting correctly. Maybe it's cross-communicating between the CCDs like it shouldn't be doing and causing a latency impact here, or penalty. Whatever the reason. Could be a game, could be game bar, could be driver, could be the chipset driver. Who knows? Who knows? Fact is, here's what it is. We have sent all of our data to AMD so they can analyze it, and hopefully maybe future BIOSes, future drivers, who knows what, might be able to fix these issues. But that reliance on the game bar and PPM, when it causes problems, these are usually the kind of problems that you see it causing: a degraded performance or a degraded experience, a performance regression. And we're definitely seeing that. Now, keep in mind, very important, this was with a fresh install of Windows. So on that 9950X, a clean, fresh install of Windows, a clean, fresh install of Cyberpunk 2077, a clean, fresh install of the drivers, the chipset drivers and everything, an update of the game bar, an update of the Windows updates, and all the store updates. So this is as clean and fresh as it gets. So that can show that even if you do that, there could potentially still be problems. But we double checked and we really did everything. We even ran the idle tasks command to make sure all idle tasks were taken care of before benchmarking and everything. So we went back and retested this several times with several reformats of Windows. And there you go, performance regression. It's possible. But even with the 9950X, it's still the same performance as the 7950X. No advantage. Dying Light 2. This one's a little bit different. We have been seeing that Zen 5 CPUs have been doing a lot better with Dying Light 2. I don't know why or what it uses that makes it different, but it is. In fact, the 7950X also does, or 50X 3D does pretty well as well, because it looks like we have a bottleneck here. So if you look at the performance difference between 1440p and 1080p, you'll see it doesn't change much on any of the CPUs, even the 7950X 3D. There is some kind of performance bottleneck happening at 1080p in Dying Light 2, and it really needs a powerful CPU to overcome that. Even at I guess you should really say 1440p is where the bottleneck's happening, because it's like that's where the frame rate stops and you can't get past that. So really, if you had a much faster CPU, you could get past that, because the 14900K does. It gets way up there. It gets way past this limit, but even it's still bottlenecked between 1440p and 1080p. You'll notice not as much difference between these two resolutions. So there, even on the 14900K, there's a bottleneck happening in Dying Light 2. It really needs a fast CPU. This is actually a really good CPU test. For whatever reason, Dying Light 2 is turning out to be a great CPU test, or a great CPU benchmark, because of these facts. So you'll see here that the Ryzen 9 9950X is showing a performance improvement over the 7950X quite a bit. I mean, that's a pretty decent performance. That's the kind of performance difference we would have liked to have seen in every game. And then the 9900X over the 7900X is a decent uplift, not huge, but it's an uplift. Again, I just wish we saw this in all the games. So Dying Light 2, real interesting there for CPU benchmarking. All right, Horizon Forbidden West, a brand new game that just came out on the PC, and we're pretty much seeing kind of similar to Cyberpunk here. We're seeing that there's no difference between the 9950X and the 7950X. The 9900X is maybe a slight regression, but really all the same. I mean, these performance numbers are so close together, you might as well just say they're practically the same. And keep in mind, this is a manual run-through in Horizon Forbidden West, so it's possible there's some variance there. So margin of error, I would say, they're all pretty much the same performance. So in other words, no performance difference. In Returnal, 9950X, 214, 7950X, 212. So again, very slight, just really almost non-existent. 9900X is 210, 7900X is 208. Very small there as well. 7950X 3D is actually matching the 9950X, so you could say that's kind of impressive if you look at it that way. And the 14900K is 215. There is a difference between 8 and 15 here, so it is using the CPU, not as much as some other games, but there's a little bit of a difference there. Starfield, this one we had expected some bigger differences and really didn't see them. Now, similar to Dying Light 2, this one has a bottleneck between 1440p and 1080p too on a lot of these CPUs. Starfield does need a powerful CPU, and we're seeing that here. To push beyond even from 1440p to 1080, you're going to need a real good CPU. And we do see that the 9950X is, well, same performance as the 7950X. So it's no advantage compared to the last generation. And then the 9900X is in fact a regression at 1440p compared to the 7900X. So a little bit underperforming for the Zen 5 CPUs in Starfield here. But if we look at, for example, the 7950X 3D, much bigger. So that 3D V cache definitely helping in Starfield. And then the 14900K is definitely a lot faster. So it does show that Starfield does need a faster CPU at 1080p, or it would help with a really fast GPU. So that's what we're looking at in the gaming performance. So the two games that showed the most difference here would be Alan Wake 2 with a 4% advantage on the 9950X versus the 7950X, and then Dying Light 2, and that was like a 15% advantage with the 9950X versus the 7950X, but that's an outlier game. None of them else show differences that big. And then we are seeing some performance regressions with the 9900X in games. And possibly with the 9950X, maybe it's just performing better, but it's also regressed a little bit and not performing as well as it could be. So something to keep in mind. Let's now look at the 9700X and 9600X in gaming. Okay, similar to the last graphs, I am now looking at the Ryzen 7 9700X highlighted here. And then also we do have the 9600X. It's not highlighted, but it's also on this graph as well. And again, same comparisons, same setup as the other game graphs. We are now comparing to a 7800X 3D, which you're going to find out that it's on the top all the time. A 9600X, 14700K, 14600K, 7600X, and 7700X. All right, looking at the 9700X and Alan Wake 2. 1080p 174, and if we go down and look at the 7700X, that's a pretty decent uplift. It's not huge, but it's one of the bigger uplifts actually, from 164 to 174. It's 10 FPS. So if you look at it, yeah, the 9700X is actually a pretty good uplift over the 7700X in Alan Wake 2, and we saw that in the 9950X as well. Alan Wake 2 showed a bigger advantage than other games, so that's something. The 9600X is up here at 176, and yeah, it's actually a little bit faster than 9700X, interestingly. And if we look at the 7600X, yeah, that's pretty decent. So in Alan Wake 2, actually, these two CPUs are a pretty decent uplift over their previous generation. And they're very close, actually, to the 7800X 3D. I mean, you see the 9600X coming in close here to the 7800X 3D. It still takes the cake. It still wins, but much closer, and that allows it to outperform the 14700K and 14600K. So it's a good result in Alan Wake 2, and we saw that in the other sets of CPUs. Alan Wake 2 seemed to showing a better result there than some other games. Assassin's Creed Mirage. 9700X over the 7700X. It's an advantage, 192 versus 198. Not huge, but it's there, a more notable advantage. 9600X, definitely a bigger advantage over the 7600X. So we're actually seeing a pretty decent scaling there between the 9600X and 7600X. And of course, 7800X 3D is way out there with 223, and that beats the 14700K and 14600K. But the 9700X, it's closer to the 14600K, but it doesn't quite outpace it. And the 14700K, that still wins over the 9700X here. So 14700K is faster here. And what was it here? Yeah, it was here. Here it was, the 9700X was just a little bit faster than the 14700K. But here, the 14700K, definitely much faster than the 9700X. Now, an Avatar, similar to the last set of graphs, a UE5 based game with ray tracing turned on all the time, can't turn it off. We are not seeing a difference here at 1080p, and that's similar to the last set of graphs. We just wanted to show this because some games can have a non-result where there is no performance difference, and that's important. It is important to show because that is a real-world thing that will happen, can happen in games. So I just want to show that as an example of that. Even the 7800X 3D is just 171. Fastest is up to 172, so we're talking a frame difference here. Cyberpunk. 7800X 3D does phenomenally well. 227, it's way up there. 9700X is 215, and the 7700X is 208. So we're actually seeing an okay bump here. It's not huge, but it's okay. It's all right. It's there. It allows the 9700X to outperform the 14700K, so that's positive. A little bit of an outperformance there. And then the 9600X versus the 7600X. Yeah, a little bit more there too. We're getting a little bit better scaling here. Now, we didn't see this in the 9950X and 9900X. Remember, those now have that core parking and the PPM provisioning thing. That was not so good in Cyberpunk. But these CPUs, which don't require that, they're scaling pretty well compared to their previous generation counterparts. I mean, it's decent. It's not mind-blowing, but it's all right. Now, Dying Light 2, as we mentioned, is showing a bigger uplift than some other games, and we're also seeing that here. Again, that same bottleneck between 1440p and 1080p. Definitely a bottleneck between those resolutions. It looks like we're maxing out at 1440p, and then it just can't go faster than that without a faster CPU. That's what it comes down to. So you need a much faster CPU to get past the 1440p performance. So when you go down to 1080p, it's just still bottlenecked at that performance. That's where it's being bottlenecked at. The 14700K and 14600K, however, are much faster in this game, doing really well. But then the 7800X 3D comes in, and it's about 194. So it's up there. It's the highest out of all the AMD CPUs. But the new 9700X, it is faster than the 7700X by a decent amount. That's a decent uplift. And then also the 9600X versus the 7600X, that's a decent uplift in gaming performance there. That's not too bad. So Dying Light 2, yes, it's an outlier, but it's a good outlier, and I wish we had seen this kind of scaling more in more games, but in this one at least, that shows that. Now, Horizon Forbidden West, brand new game. 7800X 3D, about almost 180 there. So 7800X 3D is doing the best, absolutely the best. 14700K is matching performance with the 9700X. So the new 9700X is not any faster than the 14700K here. It's exact same performance, but that is a bit faster than the 7700X. So there is an uplift from the previous generation. And then the 9600X, it's a bit faster than the 7600X. There is an uplift. It's not a huge uplift, but it's benchmarkable. It's there. There is one. Returnal, 9700X here, and that is pretty much, yeah, it's faster than the 7700X. More decent in this game, actually. 9600X is 213, 7600X is 206. Yeah, I mean, that's not a terrible increase there. Looks like these CPUs are the slowest here, and then it kind of jumps up here, and all these are very similar. 7800X 3D still at the top here in Returnal. And then Starfield. Starfield, very interesting game. 14700K and 7800X 3D at the top of the graphs here. They're doing really well. That 7800X 3D just proves to be the best thing. But the 14700K is no slouch. Just keep that in mind. 14700K is really no slouch. It is a powerful CPU for gaming, so don't underestimate that. There is a big power difference between it and the 7800X 3D, but if you're just, if you want to do gaming and you want some productivity, along with that, more than 8-core 7800X 3D, the 14700K really is a viable option for gaming and productivity. So, that's interesting. So the new 9700X though, yeah, okay, it's not matching the 14700K. So it's definitely it's not any faster than the 14700K here in Starfield. The 14700K is beating it. Compared to the 7700X, yeah, we're not really seeing any performance difference here. It's really, really similar. And it's also the same between the 9600X and 7600X. It's also very similar performance. And we saw that as well with the 9950X and 9900X. So Starfield, for some reason, these new CPUs aren't really showing an advantage. Maybe they're underperforming for whatever reason, but that's what we're seeing in Starfield. So don't know what to say about that. That's what we're getting, and that's what it is right now. All right, let's do a quick summary of everything we've learned today. All right, well, that has been our overview, summary, long review, deep dive of performance on the Ryzen 9000 series CPUs that were just recently launched. First of all, thank you for watching all the way through this video. If you have, thank you for watching and spending your time with us as we go through all this. As I mentioned, we have all of this detailed in our written reviews where the specifications are, the analysis of performance, the percentages, as well as our thoughts and opinions in the conclusions. Each CPU has its own separate review, so make sure to check them out for the one you're interested in. I am now going to summarize my thoughts on them. I have more thoughts and opinions in the actual article, so check that out. But here is my quick thoughts on these CPUs. There is a bigger uplift on the single core, single thread performance with Zen 5. We have seen that. You just cannot deny that fact. If you're using workloads that have a single core or single thread uplift, or you're doing workloads that need that uplift, a Zen 5 CPU is going to provide that over a Zen 4 CPU. You're going to get that performance boost. Now, that's not necessarily going to exceed the competition's 14th gen from Intel. It's pretty much just bringing Zen 5 up to the level of the 14th gen, which may be a little bit scary for whatever Intel comes out with next generation. Perhaps maybe that's faster in the single thread, single core stuff. It seems to me like Zen 5 fixes the single core, single thread performance of Zen 4. Not that it was bad in Zen 4, mind you. Everyone loves Zen 4 CPUs. They're good CPUs. They're good for gaming. They're great for gaming. They're still, in fact, the better value for gaming. It's just that this brings it up to the level of what you would expect in 2024. So that's good. That's a good thing. There's not a huge uplift in the multi-threading department because it's still the same core and thread count. And when you look at the power envelope that these CPUs are set within and the maximum boost clocks that they're allowed to boost to, you'll find that that's actually lower than Zen 4 CPUs, the Ryzen 7000 series. The boosting clock speed is lower on all core. And in fact, we have frequency testing we did in our written articles where we showed what our maximum frequency was with all cores maxed out. And we found the frequency was running lower. It does hit its maximum boost clocks on single core and single thread, and so a lot of that performance is happening with that frequency. But the frequency for multi-core and multi-thread stuff is lower than the previous generation, and a lot of that may be due to the power envelope they're set in. But whatever the case, it is what it is, and so that means to get a performance uplift, you pretty much need an architectural change. And there are some architectural changes that bring a multi-thread performance uplift, but it's not major. And it also is extremely dependent on the workload you're doing. For example, it is clear that Zen 5 is built for workstation and server workloads, AVX, AVX 512, these things it is incredible at. If you have those type of workloads and you're doing that, Zen 5 is a no-brainer. Go for it. You're going to save power, and you're going to get incredible performance over the previous generation. However, for the everyday user, for the me and you using our computers for, office type of work, if you use Word, you use Excel, or heck, if you're just in Chrome a lot and you just, a browser-based work, you work out of your browser, you're not really going to see a performance advantage that is noticeable versus the previous generation. For those type of workloads, Ryzen 7000 series is still the best value. Now, as for gaming, well, that depends. If you want to do productivity, right, and you want to do gaming and productivity, then you're looking at a 12 or 16 core CPU. I have my doubts about the 9950X and the 9900X for gaming because of the new fact that you have to have the chipset drivers installed and rely on core parking and the PPM provisioning stuff from the chipset driver and the Microsoft Game Bar. The reliance on that has not been easily accepted by people who have thought about going to, for example, a 7950X 3D. The 7950X 3D is, of course, the 16-core Zen 4 CPU with the 3D V-cache. It was supposed to be the best of all worlds. You have the 16-core for productivity, 32 threads, and then you have the 3D V-cache for gaming. But that requires core parking and reliance on Microsoft Game Bar. And when it doesn't work, the latencies are bad. And when that's bad, your gaming performance suffers. A lot of people have not wanted to go with the 7950X 3D, but instead go with the 7800X 3D because of its single CCD nature. And so the same could be true for some people if they're thinking about a 9950X and a 9900X as the be-all CPU for productivity and gaming. They would be great in productivity. There is no doubt the 9950X and 9900X are great for productivity. But are they really the best thing for gaming? One can argue that they are not because of the reliance on core parking, PPM, Microsoft Game Bar, all of that stuff. You can argue that's not a good setup for gaming. Therefore, if you want productivity, then sure, 9950X, 9900X. But if you want gaming, then maybe you just do 7800X 3D. Unless you also need productivity, which in that case, I would say 7950X is maybe the best of both worlds. And in fact, that's kind of where I want to steer this commentary. And now I'm going into, thoughts, opinions, commentary. These are my opinions, purely my opinions. So take that for what it's worth. My opinion is the Ryzen 7000 series right now are a really, really good value and a better value compared to the Ryzen 9000 series CPUs. Simply because, and a very simple fact, is that pricing is much lower on the Ryzen 7000 series over the course of time that they've been out. They have been out for 2 years. So they were launched at a certain MSRP, but now the street pricing is much lower and much more affordable. And that makes them much more appealing when you compare that to the current MSRP pricing of the Ryzen 9000 series. Now, I say right now, and I specify the words right now because that will change in time as well. So keep that in mind. The opinions I have now about the value of Ryzen 7000 series versus 9000 series will and could change over time because eventually what's going to happen is the Ryzen 7000 series will eventually dry up in inventory and go out of production, and you just will not be able to buy them anymore. And then give it more time, the Ryzen 9000 series will drop in pricing. So with both of those things happening in the course of time, the Ryzen 9000 series will eventually become the better value and will eventually be the better buy. It isn't right now, absolutely not right now, but it could be in the future. So you want to keep those things in mind when you're looking for CPUs. I would say, my opinion, is that for 2024, for the rest of this year 2024, Ryzen 7000 series is going to remain the best value if you're looking for the best all-arounder CPU. If you want productivity with a 16-core or 12-core CPU, but you also don't want to sacrifice or have the gaming experience be any worse, you want it to be a good gaming experience too, the 7950X or 7900X is going to be your best buy. And that's going to have the better pricing. And that's going to be the best all-arounder CPU. Now, if you purely want productivity and you game lightly and you don't game heavily and you're not a huge gamer and you want all productivity, then the 9950X is appealing because it does have the faster single core, single thread performance, and it does have a lower power. has a lower PPT at 200 watts. So it will run at a lower power when you're doing those high-end productivity workloads. So the 9950X is appealing in the right situation. And it's also, again, very appealing for people that use AVX or AVX 512. If you're using the right workload, you're going to see 70-80% advantage over Zen 4. So in the right workload, the 9950X and 9900X are very appealing. And if you're all productivity and light casual gaming, they're fine for that as well. If you're heavy gaming and just do nothing else but game and productivity is lower on your ranking system, if you do less productivity stuff, you can't beat the 7800X 3D right now. You just cannot beat that for gaming performance. I will stress though, the 99 or 9800X 3D will eventually come out. Who knows when, who knows how much, who knows how to perform. I don't know. We'll look at that when it comes. But that could also be the best value for gaming. We'll have to see. So either the 7800X 3D now or maybe the 9800X 3D in the future. One of those X3D parts is clearly the best for gaming. Nobody can deny that. Nobody can doubt that. That's what you should go for if you just want pure gaming. But of course, gaming is not the only thing people do. Now for the 9700X and 9600X, those CPUs are a little bit harder of a sell because, once again, the 7700X and 7600X CPUs are cheaper now. And yes, those are a higher TDP part with a higher PPT. However, they are equally as fast in a lot of situations. And with the saving in money that you make from buying those CPUs, you could then put a little bit more money into your GPU. And that's what I would do. Save a little money and get the 9700X, for example, save a little money and get the 7700X, for example, and put the money you were going to spend in getting the 9700X and put that into the next tier GPU, a little bit higher up on the GPU. That's the smart play if you're into gaming, because if you're buying a 9700X or a 9600X, your productivity is probably not extremely high on your list. You still want to get things done with your computer, obviously, but you're not a hardcore renderer. You're not a hardcore transcoder. You're not a hardcore, multi-application user all at once on your computer. So maybe you're all right with going with that 7700X and then spending a little more money on the GPU for a little more gaming. That's an idea too. So let's also talk about coming from previous generations. If you're on Zen 3 or AM4 based platform, then I would say it's now safe to jump to AM5. A lot of people have been worried and wondering, should I jump to AM5? How long is this platform really going to last? Well, AMD has now said 2027 plus. 2027 plus, the AM5 platform will have new products. Everyone is pretty confident that Zen 6 will come out on AM5. So we've had Zen 4, Zen 5, and then Zen 6. It is now a safe time to jump onto AM5. The best entry-level CPU to enter on to AM5 would be a 7000 series because of the price. So if you're still skittish about it and worried about it, it would be a good idea to get like a B650 or 650E, or maybe the new 800 series chipset motherboard. Jump onto that and then get like a Ryzen 5 or Ryzen 7 7600X or 7700X. With the lower price of that, a 7600X, for example, that's a really good entry-level CPU to enter into the AM5 platform, and then you'll have the option to upgrade to Zen 5 if you want to. So a good move might be to start with something like a 7600X at a cheaper price, and then if you need more cores, then you jump up to like a Ryzen 9 Zen 5 part, like the 9900X or 9950X. You'd be able to make that move by jumping onto AM5, and then maybe in the future Zen 6. So if you're on previous generation, it's a good time now to jump onto AM5. DDR5 is at better prices. Motherboards are finally at good prices, especially for the B650 chipsets. And there's some good motherboards out there. And then the CPUs, the Ryzen 7000 series, are at much lower prices now, and for the rest of 2024 will be. And then you'll still have the option to jump onto Zen 5 if you want, Ryzen 9000 series, and then maybe Zen 6. And as for the competition, if you're on Intel, this might also be a good move because on LGA 1700, 12th, 13th, 14th gen Intel, we are now at the end of that socket. 14th gen is it. We're at the end of that socket on Intel. So their next CPU, Arrow Lake, will be on a new socket. So yeah, I cannot recommend going to a 14th gen Intel CPU right now because that makes no sense. It's at the end of its life, pretty much. It's at the end of its socket. And with the instability issues that everyone's having, I couldn't recommend those CPUs anyway. So until all those problems are really fixed and all, and those CPUs come down in price, when those CPUs do come down in price more, I will say the 14700K is an interesting CPU. It's actually not terrible. It has really good gaming performance, really good single core and single thread performance, and really good multi-thread performance too because it's got a higher thread count. So the 14700K is actually a very appealing CPU to me that if you really wanted to go with that, that's what I would recommend. But again, it's at the end of the life on that socket, so you won't be able to upgrade to anything. You just have to know that that's all you're going to get on that. But AM5 really, I think that has a long life ahead for it, and it'll give you options. So I think it's a great time to upgrade to AM5 now. We've got the 800 series chipsets coming out, and we'll take a look at those when they come out. We have, of course, the X3D components or CPUs coming out, maybe the 9800 X3D 8-core. Don't know if there's going to be a 12-core or 16-core X3D. We'll just have to wait and see. Will there be other changes to that 3D V cache? We don't know. Will they be overclockable? AMD is leaning toward that narrative that they will be overclockable in some way, maybe turning on PBO and that sort of thing on those CPUs. So that could be advantageous as well for a Zen 5 CPU. Would be like a 9800 X3D with maybe PBO turned on. Well, that to me sounds really appealing for a gaming setup. So keep all those things in mind. We'll have to look at that as it plays out. And overall, I will say that the Zen 5 launch has definitely had its ups and downs. It's been all over the place. It's been a roller coaster ride, not just for you reading these reviews and everything, but also for us reviewers. It's been a roller coaster ride because we were also dumbfounded a lot of the time by the performance we were getting and wondering why, and maybe expecting a little bit more, thinking it would be more than we got in several areas. But all I can say is that perhaps over time things will improve. New BIOSes, new AGISA versions, new drivers, who knows what else. Maybe Windows updates even could improve many things, scheduling and that sort of thing. The fix, I will also mention the fix about the performance issue with Windows administrator, the difference between Windows administrator account and or just elevated privileges. That may or may not be an issue. I will just speak briefly on that. All of our testing was done in the exact same way on all the CPUs. That means we create a local account when we are installing Windows. It is elevated to administrator rights, but it is not the secret administrator account. It is not that secret account. So it is the normal way that a user sets up Windows. But all of the CPUs were tested in that same way, so they're all comparable, and it's a fair comparison. And that's how we always test all of our stuff, GPUs and CPUs. That issue may simply be related to certain security features in Windows being disabled under a true or native administrator account, which could improve performance. If you take away security mitigations, performance could go up. But nobody should run with the pure administrator, hidden administrator account. That is a huge security risk, and that is not how Windows is meant to be run on your local machine. So just keep that in mind. That could just simply be because certain security mitigations are taken away under that account, and so you're seeing higher performance. but it's still relatively the same performance as was tested. The difference between the CPUs still scales the same. So I just wanted to mention that. I am aware of that issue, but all of our data was tested in the exact same way under an account with administrator privileges, but not the hidden administrator account, but it's always been tested that way, and they were all equal. So I'll throw that in there. And again, on the gaming testing, we tested only 8 games, so keep that in mind. We definitely need a larger sampling of gaming to test, and we're going to do that. I should also mention we're going to do PBO testing. Yes, you'll notice we did not have PBO testing here. I'm mentioning that now. I know people are going to mention it in the comments. You should have turned on PBO. You should have tested performance. I can only do so much. Only so much time to test. Only, I had to test every CPU you saw on these graphs. I had to test them all at the same time and get all that data and do it all at once. I could not also include PBO at the same time. But we are going to cover PBO. There will be follow-ups. We are going to enable it. We are going to compare PBO versus non-PBO performance. That will be done. You will see performance on our written review website, thefpsreview.com, and I will make a YouTube video about it to show that performance when I get that as well. PBO will be tested. In addition to that, I mentioned a big game roundup. We're going to do a big game roundup. Also, the non-X CPUs, I need to mention that as well. I know people will bring that up in the comments. You should have also included the Ryzen 7 7700 non-X, 7600 non-X. Those CPUs will also be tested and compared and included in the future. Again, it's all about timing. Could not get it all done in one review. We did 4 reviews for these launches, so just keep that in mind. We did 4 separate reviews, all on launch time. All of these CPUs freshly reviewed with multiple fresh installations of Windows and games and apps. So I couldn't include it all, but it will get done. So non-X CPUs included in the future, PBO included in the future, a larger game sampling included in the future, lots of follow-ups to do. We always do follow-ups. We love follow-ups around here. We love follow-ups. So just understand the first initial review you see is not the last one. It is just the start. And now we do follow-ups and find out all the unique, neat things we can test and compare now. And it'll be a lot of fun, and I'm looking forward to it. It's going to be a very fun end of 2024 doing all this testing. It is a blast. And we do it all for you. So let us know what you think below. Give us a like if you like this video. If you want to, if you consider it, consider subscribing to our channel, and we'll have more content like this. As always, this has been Brent Justice at thefpsreview.com. Thank you all for watching, and I hope you have a blessed day.